For this video, we're going to be discussing solving polynomial equations. So, to solve a polynomial equation is very similar to solving a quadratic equation because a quadratic equation is a polynomial equation. So the steps are pretty much the same. We're going to move all terms to one side of the equation. We're going to factor our equation completely. We're going to set each factor equal to 0. And then we're going to solve each one of those factor equations to get our answers. So let's take a look at some examples. I want to solve x to the fourth equals 81. So my first step is going to be to subtract 81 on both sides so that I've got my factor all by itself. Or I've got one side equal to 0. So now I've got x to the fourth minus 81. Okay, so I've got two terms, so I want to use what I know about factoring. Okay, x to the fourth is a perfect square, and so is 81. So I can square root both sides of both of these terms. The square root of x to the fourth is x squared, and the square root of 81 is 9. So this is x squared minus 9 times x squared plus 9. Okay, I use difference of squares. Now, if you remember, we need to factor this completely. So I also need to check to see if I can factor each one of these. It turns out that x squared, that's a perfect square, and 9, that's also a perfect square. So x squared minus 9, I can do the square root of both of these. Okay, and the square root of x squared is x, and the square root of 9 is 3, so I've got x minus 3 times x plus 3. X squared plus 9, even though these are both perfect squares, because of this plus sign, there's no such thing as a sum of squares, so I don't actually factor that. I can't factor that, I just leave it alone. So this can't be factored. So now x minus 3 can't be factored, x plus 3 can't be factored, x squared plus 9 can't be factored. So I'm ready to go ahead and set each one of my factors equal to 0. I've factored this all the way. So I can go ahead and take each one of these factors and set them equal to 0. For these two, it's pretty easy. I just subtract 3 on both sides. Or sorry, add 3 on both sides for this one. Subtract 3 on both sides for this one. Okay, and if I do that, that one's got an answer. Oh, here we go. Say, if I do that, on this side I get x equals positive 3, and on this one I get x equals negative 3. So those are two of my answers, positive 3 and negative 3. Now over here it's going to be a little bit more complicated because it's x squared. I could use the quadratic formula, I could use my calculator. I'm going to show you this really easy method though. I'm going to subtract 9 on both sides. So if I do that, I have x squared equals negative 9. Okay, and then I can just solve this by taking the square root. I can use square root of x squared, square root of negative 9. Now remembering what we know, the square root of 9 is 3, and to deal with a negative, what I'm going to do is I've got square root of negative 9 here, and to deal with my negative, I'm going to go ahead and put an I. So square root of 9 is 3, and then I've got an I on here. So that's square root of negative 1, right? If we think about it this way, this is the square root of 3 times the square root of negative 1. Sorry, square root of 9 times square root of negative 1. Square root of 9 is 3, square root of negative 1 is I. Now the important thing to do is whenever you do the square root method like this, you actually have two answers. You have 3i and you have negative 3i. Right? And we represent that with plus or minus 3i. So my answers to this problem, there are actually 4 of them. There's 3, negative 3, and then plus or minus 3i. So if we just review our procedure here, we got one side equal to 0, we fully factored our equation, and then we set each factor equal to 0 and solved. Let's take a look at a couple more examples. So here I've got x cubed minus x squared equals 2x minus 2. So once again, I need to get one side equal to 0, so I'm going to subtract 2x and add 2 on both sides. Notice that on the left-hand side, they don't have anything that they can combine with. So I have 4 terms. Okay, so I've got a 4-term polynomial. I need to factor it. So I'm going to use greatest common factor first off, or I don't need to use greatest common factor, they don't have one, but I can just use factoring by grouping. The greatest common factor of x cubed and x squared is x squared. So I just divide each one of these by x squared. Okay, x cubed divided by x squared is x squared divided by x squared is 1. Over here, their greatest common factor, 2 and 2 share a 2, and I want to use the sign of the first one. Negative 2x divided by negative 2 is x. 2 divided by negative 2 is negative 1. So I get x squared times x minus 1 minus 2 times x minus 1. I'm going to rearrange these into x minus 1 times x squared minus 2. I need to check to make sure neither one of these can be factored. This is linear, so it can't be factored. X squared is a perfect square, but 2 is not a perfect square, so that can't be factored. So, whoops, I'll move that around. Come on. So I can go ahead and move into setting both of my factors equal to 0. So I have x minus 1 equals 0 and x squared minus 2 equals 0. For this one over here, I just add 1 on both sides to get x equals 1. Over here, I'm going to do what I did in the last problem. So I'm going to add 2 on both sides to get x squared equals 2. It's a positive 2. And then I'm going to take the square root. The square root of 2 is an irrational number, so we don't actually write it as a decimal. We just leave it as square root of 2. And we once again put that plus or minus on there. So our answer for this problem is going to be 1 and plus or minus the square root of 2. All right, let's look at one last example. Okay, so here I've got 125 equals negative 27x cubed. Okay, so once again, I got to get one side equal to 0, so I'm going to add 27x cubed on both sides. All right, so that I get 27x cubed plus 125 equals 0. Now, 27 is a perfect cube. That's 3 to the third power. X cubed is a perfect cube. 125 is a perfect cube. That's 5 to the third power. So I can do the cubed root of both of these. Okay, this is the sum of cubes. So if I do that, the cube root of 27, x cubed is 3x. The cube root of 125 is 5. And then remember, we use our factoring pattern. So we're going to square this whole thing. So 3x squared. 3 squared is 9. X squared is x squared. These two signs should be different, so that should be a minus. Then I multiply them together. 5 times 3 is 15x. And then I square my last term, 125, 5 squared, or 5 cubed. Ooh, this is actually wrong. This should just be 25, not 125. Okay, and then we're just going to go from here. Okay, so this term is always going to be unfactorable. Okay, so notice I accidentally, there we go. So that should say equal 0. Okay, we set them both equal to 0. 3x plus 5 equals 0, so if we solve that, we're going to subtract 5 on both sides and then divide by 3, and that gives us negative 5/3. And then this other one, okay, we can use quadratic formula. That's what I've got here, okay? Or we could use the calculator. There are all sorts of things we could do. If we use the calculator, or if we use quadratic formula, okay, we end up with 15 plus or minus square root of negative 675 over 18, which simplifies out. If we simplify the radical, okay, 675, the biggest perfect square that goes into 675 is 225. And that's 225 times 3. Square root of 225 is 15. I got rid of the negative by putting an I outside, and 3 is here. And then I can do 15, 15, and 8. Those can all be divided by 3 to get 5, 5, and 6. So my answer for this problem ends up being negative 5/3 and 5 plus or minus the square root of 3 over 6. So now you know how to solve a polynomial equation. You get one side equal to 0, you factor the problem out entirely, and then you set each factor equal to 0 and solve from there.